Hey 8th graders, today's lesson is the Force in Motion Chapter 2 Modeling Practice, and this is going to be the last assignment that we really have before we take our little modeling quiz on Chapter 2 and our final test or quiz on Chapter 2 as well. So keep that in mind, that will be following this assignment. Okay, so your learning targets for today: I can model how the velocity changes with objects of different masses when an equal force is applied, and even if we have two objects of different masses, how their velocity might change as well. Okay, and we've been going over Newton's second law a lot in class as well. So again, this is kind of our last little assignment. To your OneNote, you need to add key concept number 5. If the same strength force is exerted on two objects, but the objects have different masses, the object with less mass will have a greater change in velocity. Okay, so moving on to your bell ringer for today, you're going to start by making some predictions about these two pucks that you see in the image. So make some predictions about what will happen in the sim when you exert the same strength force on two objects of different mass. You're gonna then, after your prediction, run the test in the sim, and then when the tests are complete, you're gonna think about how you would answer this question. Why did one object stop more easily than the other? Be prepared to share your ideas with the class. So obviously you guys are working from home, so you don't have to worry about that last part there. Okay, so here are your predictions. You'll use your draw tool to answer them. If your goal is to make these objects slow down, in which direction should you apply a force? So you guys will go ahead and make a prediction based on the image you saw here, so you guys can see what their movement is like or their initial velocity before you will apply a force. Okay, so up, down, left, or right, circle your answer there. And then object B is more massive than object A, so object B is heavier. Okay, if you apply the same strength force, we're going to do 4 clicks to both objects. Which object will have a greater change in velocity? So as far as speeding up, slowing down, starting, or stopping, which one's going to have a biggest change in velocity when we look at the initial versus the final velocity? Okay, so go ahead and make your predictions there, and when you are ready, move on to slide 5. Okay, on slide 5, you have your instructions, and you also have the link to the sim. Okay, open the Force in Motion sim and select the 2.3 warm-up from the menu. So when you guys pull it up, it should automatically pull up for you, but just to kind of double check, here's our 2.3 warm-up. You can see the same objects that you saw in the sim. Okay, press run then play. Press prepare force to pause the sim while you set up your forces. So you're going to do the prepare force button. And then in the force panel, select object A and set up a force 4 clicks in the direction that will make the object slow down. So what you guys predicted above. You guys are going to do the same thing for object B. You're going to apply the exact same force, so 40 newtons, 4 clicks. Okay, and then you'll go ahead and press exert force and observe how each object's velocity changes. Okay, from the analyze portion of your sim, so after you run, you prepare your force. Okay, and then you guys do your 4 clicks, 1, 2, 3, 4, 1, 2, 3, 4. Okay, you'll exert that force, and then you'll go into analyze to get the rest of this. So what was the direction of the force you applied? You guys can see that I did it to the left. And then from your analyze page, you guys will do what's your change in velocity. So if I go ahead and just take a look at that now, I didn't exert a force, so you guys will see there's no change in velocity for either. But you guys, when you actually exert those 4 clicks or 40 newtons of force to the left, will see a value for the change in velocity. So go ahead and record those right here and then answer this question. Object B is more massive than object A. If you apply the same strength force to both objects, which one will have a greater change in velocity? So you guys made a prediction on slide 4. Now I'll go ahead and answer the actual question where you guys write in your prediction. Okay, if you need to, take a second, pause this video and complete your notes and your bell ringer. Okay, moving on to activity 3, you guys are going to do a little different sim in the PhET link that we've been using a couple times since we started this whole unit. Okay, and this one you're going to open it up, and for this one we're going to do the little guy on the skateboard. So this is our motion. Okay, and then every time you run this sim, you need to make sure all 4 of these boxes are checked so you can see the direction of force, the values of the force, the mass of each object, and the speed that your object is moving once we apply a force. So go ahead and click on your motion, all 4 of these boxes here. What you guys are going to be doing is, obviously you're working from home, so you don't have a partner to be, but with that being said, it'll be easy for you to kind of start this, get this going, and then time it using your phone or whatever you guys have available, or you can get a parent, guardian, sibling, friend, whoever to help you out with this. Okay, what you will be doing is applying 300 newtons to each of these objects on the skateboard. I'll show you guys how to kind of max that out. And then you guys will be timing the time it takes to reach the final speed here. So collect data using an online stopwatch. Okay, so again, time it takes to reach maximum speed. You guys will know it reaches maximum speed when the little guy, so you've reached maximum speed when the speedometer is at its highest reading and the android has fallen on its face and pushed the object on its own. Okay, so you guys will go ahead and do this. You'll start with the crate on the box, so we've already started with that there. And then what you guys are going to do is if you go ahead and pause it, you guys can go right up to 300 newtons. So if I'm looking right here, I see 284. I want it to be 300. You guys can fine tune with these little clicks. And then you're going to go ahead, you're going to hit start on your stopwatch. I'll go ahead and just pull up a quick stopwatch for you guys, and I can help you guys out with this. It'll probably appear backwards on yours, but that's okay. So I'm going to go ahead at the same time with my stopwatch. As I hit play here, I'm going to hit start on my stopwatch. Okay, and then I'm going to watch until it reaches its maximum speed. Okay, and it's going to stop right about there. Okay, I was not quite Johnny on the spot, but when that android fell down, that's about 8.5 seconds. Okay, or excuse me, about 8.1 seconds. So then I'm going to go ahead and type in my 8 seconds there. Okay, so all of these should be pretty quick and in seconds, and then you're going to switch it out for the 200 kilogram fridge. So go ahead and reset. We're going to do the fridge instead, get rid of the box. And again, I'm going to pause it, max it out at 300 newtons, and then hit start right at the same time I hit play. And then I'm going to stop my stopwatch the second that little android lets go, and my speedometer is maxed out here, and the guy has fallen on his face. Sorry, this is taking just a second longer. Had to do the heavier objects first, didn't I? So right about now. So I did a lot better on that one. I got 27 seconds. Okay, so I just kind of rounded up from 26.94. Okay, so you guys will go ahead and continue to do the kid on the skateboard, the garbage can, the man, and then what you're going to do is you're going to take the time that it takes to push your present, and you're going to kind of figure out, so notice this pink font right here. That is a number where you guys need to fill in and kind of guess how many kilograms you think it is based on the times you guys have gotten for your other ones. Okay, all right, so go ahead, moving on to the next part. You guys will answer this question. Which object took the least amount of time to reach maximum speed? Use your draw tool to circle either the crate, the kid, the fridge, the garbage, the man, or the present. And explain why. Use some vocab for class. So the vocab that's really most relevant to us right now is force, velocity, exert, or mass. Okay. And then finally, which object would take the highest amount of force to move? So kid with the fridge on top or the man with two crates. If you're not sure, go ahead and reset and say, all right, we've got kid with the fridge on top. Okay, because it makes sense that we can put a refrigerator on top of a kid. Okay, or would you look at the man with two crates on top of him? So here's our man, and he's going to have two crates. So you guys can look at the different masses. If you guys click your mass, you guys can kind of add those up versus the kid and two crates and figure out which one is going to take the highest amount of force to move, and then why. Use the term inertia in your answer. So this is a little throwback from chapter 1. Okay, go ahead, pause this video, take a second to complete activity 3 FET, and then we will move on to the last part of this. Okay? All right, we've used this example a lot in class, so I want you guys just to stop and think about it again. Imagine an empty shopping cart and a full shopping cart sitting still. If you push them both with the same amount of force, which one would speed up the most? So maybe you're racing towards the end of the aisle, whatever the case is. I push them both with the same amount of force. One's heavy and one's light. Which one's going to make it to the end of the aisle or speed up the most or hit the highest velocity? Okay. So with that being said, you guys are going to move on to this last part of the sim. You guys are going to open the sim link. This is just the normal sim link that you guys have been using all period. Hopefully it's going to work because it just kicked me out of the other one. And then I'll go ahead and read your instructions while that loads. So remember that in chapter 2, we are studying objects of different masses and how they move differently if we exert the same strength force on them. So you're going to go ahead and grab 3 pucks. 0.5 kilogram puck is going to represent a smaller mass. So if you guys kind of remember what we've been looking at is, at first we looked at the ACM pod and said, hey, what if something was wrong with the thrusters? and that caused the pod to move away from the space station. You know, if we didn't have enough thruster force, the pod would only slow down, eventually it would hit the space station, bounce off, and move in the other direction. Or if we put too much thruster force on that pod, it would just turn around and change its direction, and it would move away from the space station. What we found out then is that the pod didn't have, or the thrusters on the pod didn't have anything wrong with it. Therefore, it had to maybe do with the mass of the pod. Remember that our little ACM pod's out collecting asteroids. So normally maybe it could have collected less asteroids than normal, or it could have collected more and been heavier than normal. And that would affect, you know, if we're putting a medium strength thruster force on, that would affect how that motion changes when we apply that thruster force based on the mass of the pods. So all of these pods are moving at a medium speed, so set all 3 pucks to move at 2 centimeters per second to the right. Because nothing was wrong with the thrusters, the pod always fired with the medium force to the left. Okay, so object A had the smaller than normal mass. So again, you guys should have picked your objects. Oh, there you go, get it loaded. Okay, so again, my 3 pucks, we've got 0.5 is the smaller mass. So object A, we're actually going to delete this one. We're going to pull out the 0.5. That's our new object A. We're going to have a 1. That's going to be our object B. And we're going to have a larger velocity one there. That's going to be our object C. We're going to set all of those with a velocity to the right of 2. That's going to represent our medium, our medium velocity that our space pod was moving at. And again, what we're demonstrating here is how the different mass, maybe this would be our normal pod, this would be our pod with less asteroid samples and therefore a smaller mass, and then this would be our pod with more asteroid samples and therefore a larger mass. So how would they move differently if we were to put the same medium force on them? Okay, so object C had a larger than normal mass. What change in motion did you observe when it was hit with the force of 2 clicks? So we're going to go ahead and look at these. I'm going to shuffle them out of order here. We're going to go ahead and hit run and then prepare our force. And we're going to put a medium force, so 2 clicks to the left, 1, 2 on each of these. So all the same unbroken normal thruster force, and then exert our force. Okay, so you guys kind of got to see how differently these pucks moved. Okay, so object A had the smaller than normal mass. What change in motion did you observe when it was hit with the force of 2 clicks? Circle your answer there. Object C had a larger than normal mass. What change in motion did you observe when it was hit with a force of 2 clicks? So if you're not sure, you guys can always go in here and say, all right, here was my change. It turned around and went in the opposite direction. Okay, so it was going 2 to the right. Then it turned around and went 2 to the left. So that's a change of 4 if you guys look at like a number line. Okay, this one stopped moving. So it was going 2, it stopped moving. That's a change of 2. And then this one was 2 to the right. It only slowed down, and that's a change of 1. So which one had the biggest change of velocity? Why was the change of motion different for all 3 pucks? Okay, so go ahead, take a second, complete those. I kind of already showed you in the sim, so you really don't have a lot to do in the sim. Just answer those 3 quick questions on 13, 14, and 15, and then we will move on to 16. Okay, so in this activity, you guys are going to model your ideas about how a more and less massive pod's motion would be affected by the same strength of force. Okay, so this is kind of getting us ready for what we're going to do in our next lesson when we do our modeling quiz. There's not going to be as much modeling as you guys have seen in chapter 1. So this is representing our small mass pod. This would be our normal ACM pod, and this would be if our ACM pod were collecting more than normal samples. Okay, notice that they're all moving with a medium speed to the right, which is what we know of our ACM pod, and we're all going to put the same normal medium force to the left on those. Remember that with this one, okay, we had our medium massed object stop moving. So I'm going to go ahead for you guys right now and insert a little text box here and say this one is now at rest. Okay, so it stopped moving. Okay, so we know now that that one's done moving. So how would the other 2 move comparatively? So that's your guys' job right now, is to kind of figure out how they're going to move differently. So in your after force, go ahead and do your smaller than normal mass pod. What's it going to look like after we apply a medium force? And then do your larger than normal mass pod. What's that going to look like after we do a medium force? If you're not 100% sure, go back to the sim that we just did. Okay, and then on the next one, you guys are going to do the force. So in this one, we have all 3 of our pods, small, medium, and large mass pods at rest. you guys are going to model the force on this one to cause them to all have the same change in motion. Okay, so all of these objects after our force are moving with a medium velocity to the left. So what size of force would we have had to put on the small mass puck to get it to move with the medium velocity to the left? Same with our medium. What force would we have to do to get it to move to the left with the medium velocity? And finally to your large, what kind of force would we have to put on this to get it to move to the left with a medium velocity as well? Okay, once you guys are done with that, you can go ahead and pause this video and we'll come back and finish the last little part of this assignment. Okay, last little part, quick little sim challenge. Your goal is to make these objects stop, to which you would need to exert more force. So if you guys look back at the sim from the very beginning, we had object A and object B. So I'm going to open this up. This is going to be the 2.3 warm-up. So you guys are kind of just revisiting this. This one's a little tricky. Okay, B is a very heavy puck, and so when you guys do this, you're going to have to prepare more than one force to get B to stop. Okay, then you're going to have to add up each of those pink arrows to figure out, all right, how many newtons did it take me to get this to stop? Obviously, we know by now from chapter 1 that in order to get both of these objects to stop, we have to put a force in the opposite direction. Okay, so we can go ahead and take a quick look at just A here, and we can say, all right, I'm going to run. I'm going to prepare my force. And then what you guys can do is you guys can just experiment around to see, all right, how much is it going to take to get A to stop? Okay, I'm going to go ahead and just try out that and see if that works. Okay, that one was too much. It moved in the opposite direction. So if I go ahead and look at my analyze, okay, I put 60 newtons of force, and 60 was too much. It turned it around and moved it in the other direction. So I can kind of experiment from there. What I do know is that this object is 0.5 kilograms and this object is 4 kilograms. So you guys might be able to use that to kind of help you out and say, all right, I'm going to need a lot more force than this one, okay? Probably about 8 times as much. Okay, so I want you guys to really think about that and then try it out, see if you can get both objects to stop. Okay, if you guys can complete this without any help, it is worth an extra credit point. Okay, but you do at least need to get A to stop for regular credit. Okay, B is the tricky one to get to stop. So force needed to stop each object in newtons, and then the direction of force, I already gave you guys those answers. So it's really down to how much force to get A and B to stop. Again, you have to do A. B, if you guys can get it correctly, is extra credit. Okay, and then finally do your exit ticket for the day. And that is it for our lesson. I hope you guys are having a great day, and I'll talk to you later. Bye.